So first of all, I'm going to be better about uploading these recordings to YouTube.
Heard it here first.
New Year's resolution.
Yeah, Happy New Year's. I'd like to get everyone back. Got some new faces joining us for SimPEG meetings today, so we might do a quick introduction, just kind of go around really quick. Anyway, I'm Joe Capriati, I'm leading SimPEG development here. I'm postdoc at UBC, so I'm in every once in a while here, but always online.
I'm Jorge Lopez. I'm a postdoc here at UBC too, and I'm working with a UXO classification problem with electromagnetic data.
I'm John Guy. I'm back at school doing some graduate stuff and hopefully do PhD. And I work part-time at DSG Physical and a little bit of researcher in development. And I used to contribute a lot to SimPEG, but it's been hard lately. But still gonna try my best. Thanks.
I'm Bart. I'm here doing a master's with Lindsay. Started this week, so pretty new. First time I saw the sun in Vancouver today, so it's nice too. I've worked 4 years almost in the mineral exploration geophysics and hopefully add some more to my knowledge here.
I think everybody here knows me, Lindsay. Exactly.
And I'm Dom, Mirage Oceans, and a contributor to SimPEG. Yeah. Where were you before? You said 4 years in mineral exploration. Can you?
Vale
Oh, nice. Right on, right on.
In Canada, where is
in Sudbury, or based out of Sudbury and across Canada. But
Yeah, and then I'm Devin. I'm a research associate. I'll probably see you in person tomorrow. I think we might have actually met once before. And I'm also doing some work relevant to Vale because they've got these plate-like structures and they're imaging things with UTEM. So playing around with some sensitivity weighting and some things that we can maybe model plate-like structures. But a lot of what I do is I sort of manage the proprietary software that we develop and give to our sponsors. So I do a lot of that stuff, but I'm also involved in SimPEG.
Thanks. Okay. Well, like I said, Happy New Year. Nice to see everyone back. As far as announcements, everything else, I don't know. We're working on getting stuff together to try to do a BERS thing at some point in the future, similar to what we did last time back in 2015, 2016.
Long time ago.
Yeah, it was a while ago. I remember on that trip stopping to on the way from Calgary to the mountains. Dom, I think you were with us in the car and we stopped at the casino and got some.
Yeah, it was a neat drive across the Rockies.
Yeah. So maybe we'll be able to do something like that again. Has anyone been in contact with Adam recently?
Adam Pidlasecki.
Yeah.
I bumped into him in Houston for SEG, but haven't really connected with him much recently. Yeah.
Just a thought.
Yeah.
Anyway. So kind of go around. I just appreciate to see what everyone's been up to as far as SimPEG related stuff. So my side, kind of quick report here. I've been taking care of a lot of like the New Year code cleanup and stuff and going through that. I'm trying to catch up on all these PRs that will be going in. I'm going through the things little by little. And we updating a few versions of things. The new version of Black should be released hopefully shortly, but it's going to reformat a lot of the code. Just be aware it'll be switched up and it'll be something there to be updated. This morning I was working on a random little issue. It seemed like there was an issue installing MOM with the continuous integration stuff that I was trying to fix. And I think I got it fixed, but it was taking up my whole morning. Very annoying. And then I would like to have a few thoughts on bumping the minimum version to 3.8 for SimPEG. Right now it's 3.7, and I think it's not many people are testing it anymore. I know Conda Forge isn't distributing packages on 3.7 anymore, so it'd be probably best to just start having 3.8 as a minimum version that's supported.
That sounds good.
Should we
There you
just
go.
move over though? I mean, we're already like 310 on our side. Like, do we
Yeah.
have to, we don't really have to creep each, each subversion, right? I think we should leap if we can.
But it's
I-
the
the minimum
minimum
version.
version.
Like the minimum supported version. Like it's fine just to abandon
Right.
3.0 and then move on to 3.8 as the minimum version, like we can all keep using what I want. At the same time, I'll also make sure it tests and installs and runs a few small tests on the newer versions as well. Just to check.
Do we have a recommendation, like in the documentation, of which version people should be working with? Or should we just say you should keep your Python up to date, or do we not
I
need to
don't.
say that?
I don't know, there's so
Okay.
many. There's so many things out there that have different version requirements.
Yeah.
Like, just support the minimum one and have whatever people are comfortable need. Yeah, so you said, Tom, you said you guys are using 310 on your stuff. Like that's distributed in Europe.
Yeah, because PyTorch has some, can't remember exactly which package, but other packages are not doing too well on the older Python. So we're just gonna fix it to
Sounds
310,
good.
but whatever.
And then, so I've just been taking care of my own stuff since I've gotten back. I've also got a few small little PRs I'm gonna put up on discretize and SimPEG related to the tetrahedral inversions and tetrahedral support. The one on discretize will be really quick and small. The second one will be on SimPEG is a little bit more thoughts, and Don might appreciate you taking a look at it. It's related to, so it's how it does this, the regularization on the tetrahedral and triangular mesh. It's also going to support at the same time the directionally dependent, like in the anisotropic kind of rotated gradients things, because you can. I'm gonna use the same thing to do that I would do for the tetrahedral stuff, because it uses the like the support that's in discretized to make those matrices already. But just take a, I'd appreciate you to take a look at it really quick and see like, okay, that kind of makes sense. And, essentially, it combines all X, Y, and Z into one operator.
Wasn't there an issue, Joe, with the weights if we wanted to do face weights or that kind of stuff, because that big stacking of operation?
I don't think so. I think it's pretty straightforward, but it just some thoughts on it. That's a separate thing that we were talking about. That was Don, that was related to the vector regularization stuff. So this is a rotated gradient thing. So if you wanted to smooth, like, you know, at a 45-degree angle as opposed to like uniform in a circle. All right, that's where I'm at. Anything to share, Jorge? Anything you want to update? Or?
Yeah, actually, I just have a quick question, because I'm planning to use the EM1D, maybe for removing the seawater response, because I'm now working with marine data, and I'm trying to see if I can model the seawater response and the sediments in the sea bottom. Just basically remove that response before I do the classification. So, but the problem is, I think the EM1D doesn't support having the transmitter or receiver inside the conductive media yet. I was just wondering in which state
When that'll happen.
Yeah,
Where we're at.
Yeah, it'll take a little bit of reconfiguring the back end, because it is like the secondary formulation, and we'd have to, and it's only looking one way. We'd have to go back and kind of redo the internals. Okay. So.
Does Dieter's code though do that
Yes.
already? So we can use his, right? Because right now I mean, the forward modeling is a good place to start.
Yeah,
Yeah.
so I would. My thoughts forward on that would be that we can base it off of what Dieter has and then kind of combine, like implement the parts that still need to be back in C, because it's a slightly different kernel.
Okay.
So, okay.
yeah, dig into in Python.
Yeah.
It's-
John?
I've been doing quite a bit of the MT version, on my third one now.
Oh, yeah.
Yeah, and yeah, it seems to be working really good, as long as you have to make the domain big enough, make sure that this boundary conditions are satisfied. And yeah, I made a function just like the DC to drape everything onto the mesh. Cause yeah, it's slightly off the stations, it just, yeah, it completely kills the inversion. No fitting.
So it's still the 3D conversion?
Yeah, 3D inversion, yeah, so this is all 3D. Yeah, I started doing a little bit of PGI playing with the 2D, but that's neither here nor there right now. But yeah, I also started trying to blend the EM, or sorry, the frequency domain and the natural source DAS stuff in with how, like we were talking about before, just like, you know, if there's a get J function in normal SimPEG, we should be trying to kind of follow the same rules. So I kind of got that stuff a little bit cleaned up. I haven't touched the potential field side yet. But yeah, just a few hours here and there, and yeah, didn't get too much into it, but yeah, if we can sit down sometime, Joe, Don, or
Yeah,
something,
that'd be useful.
have a beer and just kind of figure out what we want it to look like, I guess.
Hey, John, if I can suggest, we did a bunch of experimentation of like either draping or just adding more cells, and actually adding more cells is a nicer solution. Because when you're moving your receivers, you have a chance that you're going to move your receiver by a full cell, right? That's kind of like the worst case scenario. And that really distorts the fields. Yeah. So you're better just to augment your active set so that you're kind of like always inside, inside the domain. Yeah.
Good point. Yeah, most of ours were pretty flat surfaces, so I didn't like, it wasn't really changing too much. But definitely though, yeah, that's a good point. If there's any great photography though, it's
You should talk to Roman about what he's doing. Because I guess if it's, you have some options. If it's already in the earth, you may want to leave it alone if that's your choice, but he's projecting it to the nearest face. He's not always projecting it down. Is that sort of what you're worried about, Dom? That you want
Yeah.
Discrete surface. You don't want to just arbitrarily project it downward.
Well, you need to, somehow your receivers need to be on the active set, right? For both DC and MT.
Sure. And in some instances, you'd be projecting it up. If it was an MT station and it was within the discrete earth, you'd want to project it up to the surface.
Yeah, but every time you move a receiver, like the worst case scenario is going to be moving it by a full DX, I guess half a DX, right? Actually, you could be moving it from a full DX if you're bad lucky. In which case, that means that you're kind of shifting your poles by a full DX, and that's going to have a huge impact on your simulation. So you're better off just syncing, not moving your receivers. Receivers stay where they are relative to each other. You just make sure that the space is active around them. Yeah.
Yeah, and so are you defining your electric field measurements as a point, or are you defining each end of the galvanic receiver?
Just
I mean, for even for DC, it's the same problem, right? It's just it's a bunch of points, it's a bunch of poles. Yeah.
Yeah, so as long as those are projected to the discrete surface, you should be fine.
Anyway, we don't need to argue here, but I'm just saying, John, you should look into it.
Yeah, that's definitely, I'll check that out, because I have this recent one that I'm working with. Yeah, it's like the station was like right on the side of a cliff there, so it's just really annoyingly placed.
Yeah, exactly.
Cool. And one other thing, I do have to go a little bit early here because I have class, but back when we were talking before Christmas, yeah, I wouldn't mind, I can take charge of like the newsletter.
Awesome.
Yeah, you guys said you guys had some contacts for talks. Yeah, if you guys can get me that, I can take a look. I don't know if we want to, like, we'll release something this month. Maybe talk to Joe about your paper or your presentation and stuff and poster, or if anything's got anything, or if you got anything else, maybe the time domain stuff we can push. Yeah, I'll write up something, little topics, and
That'd be awesome.
if you got anything to put in there, let me know.
That'd be awesome. I was thinking in Joe, I think you were in the meeting, we were talking about this for speakers, the open source session that we ran, there were a lot of interesting talks and, you know, there were about 8 speakers, so we could line up, you know, people for the better part of the year. So
Yeah, if I can get the contacts, I'll bug them and see if I can get
Absolutely.
them lined up.
that'd be great. Make a note of that. Perfect.
Anything to share?
I've been more of a user than a contributor here,
You have a big CR coming in.
fortunately.
Yes, come on, first reading part.
Anything on your end?
A quick note, I will be giving a talk at the Geotech symposium with at the end of PDAC, not PDAC, Roundup. And so I will probably be tapping people for some ideas of things to talk about. So especially if you've got any good compelling examples with airborne data, being the Geotech Symposium. If you've got things that you think we should highlight, I'm all ears and would love ideas from anybody. So we'll do that. That's the end of the month.
Well, move on to the online folks. Dom, anything you'd like to talk about, Chad?
Yeah, it was actually a really productive break. I wrote the J matrix, implicit J for the 3D TEM, and then ran a bunch of a few hundred inversions, tried to get my hands dirty with the code, and it runs so far so good. It's pretty great. And then I had to review the JTVEC operation and managed to reduce the number of looping that we're doing inside. So it's going to be a bit faster. I think I can reduce the runtime still on the J matrix by kind of combining sources together if possible. And yeah, otherwise helped Jaja to write a paper. He submitted this paper to prospecting, geophysical prospecting or something about the L1 invariant, you know, the TV versus Bajan, the whole difference between TV and L1 norm gradients type of thing. So it's going to be in review.
Oh, cool.
That's it.
For the JVEC operations, did you were you able to kind of like meld like the time stepping and the field operation together? Because I remember I was spending a lot of time looking at it recently, like because the way it works, like it separates, like it does the J operation for the fields and then it projects like the derivative of the fields onto the with the source of receivers, right?
Yeah, I only look at the JTVEC, but we basically had like a full time loop and then storing all the derivatives of the fields. And then we were redoing another time loop after backward, but really we only need one backward loop because we only need to store 2 derivatives at a time and then just step backward like this.
Yeah.
Anyway, so it's a lot shorter and we only need a single time loop. And now I think I can stack basically transmitters together so that we do less AM calls, you know. So yeah, that's kind of like where I'm at now. But the inversion runs well. Like I can show you a dipping dike. It's quite nice. I don't think I can share. Oh yeah, I can share. Oh no, you need to let me share.
Are you sure? Okay, go ahead.
Which screen are you seeing?
Seeing a plate.
Oh yeah. So it's just it's a dipping plate, and then we can recover it. This is like the kind of the SkyTem time range. So from 0.1 to 10 millisecond, and then yeah, convergence looks pretty good. Basically, the kicker is that if you put a reference model, you get the ring. If you don't use a reference model, then you can converge quite nicely. Like I'm taking two Gaussian steps here, but you know, phi d is coming down quite nicely.
Sorry, Don, when you say using a reference or not using a reference model, does that just mean you're basically using a very smallness term, or?
I turned it off. I just put it to 0. Yeah.
Okay.
the thing is that as soon as you, even after the first iteration, if you put a reference model like just a half space, it's just easier for the inversion to just basically put like a conductive ring around and put nothing in the middle, because it forces basically the background in the center of the plate. Here it's just smoothing, and then with just the smoothing we can fit it quite nicely already. So it's a simple fix, but that means that we can't do sparsity because obviously alpha S is 0. So that's kind of like where I'm kind of trying to play tricks. Can we bring it back later in life, or yeah, I'm not sure yet.
What were the uncertainties that you applied to your data?
I just did a floor per time channel. So it's basically, I think I did like half the median of each time channel, I think.
Yes, like you applied like quite a lot of noise to, like I'm looking at the blue and the red. It's quite significant. Like it.
Well, so blue is real, and then red is predicted, and then black is the floor, is where the floor is at.
Okay.
The fit is really good. I mean, it's gonna. I ran a lot of those, and it's actually a pretty good fit. Yeah.
So you said this was after 2 Gaussian iterations or so?
Yeah, that's the other trick. It seems like you kind of want to go slowly. If you try to take 2 big steps, then you can get some pretty nasty space, right? So it takes longer to iterate down the target, but it's kind of a more robust way to do it. Just take multiple Gaussians and just slowly, start high beta and then slowly go down. Yeah, that'd be a way to accelerate it, but.
Well, I mean, it's essentially like a truncated Gaussian approach.
What do you mean?
When you start with like a high beta, trying to zero in on something, it's essentially the same thing as like a truncated, or not I think it is that, like there's a term for a minimization procedure where you're, sorry, a trust region, that's what I'm getting at.
Okay.
Oh, yeah, I see.
High beta is essentially a trust region approach to solving the nonlinear problem.
Yeah, you start with something very smooth and then you slowly go down the nonlinearity. Yeah, absolutely. Yeah. Anywho, so that's pretty promising.
What kind of time period, or what kind of timing did it take, or your estimates?
Timing for what?
How long did it take?
To run. Right now, it's a pretty small problem. It's about 30 seconds per beta. So it takes about like 5 or 6 minutes for this problem, but that's only like a 4x4 grid. So 16 sources and then 8 time channels, right? So it's a pretty small problem, but it's big enough to be able to test it, at least be able to see what's up. Yeah.
Anything else?
No, that's it.
Devin?
Yeah, I guess sort of fitting in with some of the time domain EM stuff. I mean, I've talked to you, Joe, and you, Dom, kind of separately and figuring out kind of where I fit into it. And I guess I would like maybe the 3 of us to get together at some point and get an explicit list of tasks for this. I kind of find myself going through and making improvements for what I need to do my work, and then finding out that maybe there's something additional that we want to change to that because it fits into something bigger picture. I'm kind of finding maybe we should get together, get a global perspective of what needs to be done, make explicit tasks, and then partition it out. What do you guys think?
Yeah, that's something I want to make sure that we're all on the same page in, is the direction that we see the time medium stuff going, and like all the little pieces that we're at. So I think I'd like to see Dom, I know you shared it at one point, your PR or your branch, that you had your Jacobian operation going on there, so.
It's in Dev's Devin's issue. Yeah, you can.
Yeah, I need to look at that, but we need to have I'm gonna get together and kind of think about it, and then we'll all come together and kind of decide.
Yeah.
Tasks that have to be done in the order that we should probably think about them in.
I guess I'm motivated to work on it. My concern is I will make a moderate improvement that will then be something that gets erased to make an even better improvement. To avoid that.
Yeah.
So what time works for you? What are your schedules like in the next even couple of weeks?
I'm pretty open. Just send a meeting invite, and then we can go from there.
Yeah.
Is there a day of the week that you prefer? Do we want to meet in person? So I'll
Sure.
propose some form of in-person meeting at UBC, let's say, or
Yeah, no, it's a good idea. In person, I think would
Sure.
be
Okay.
more valuable. Yeah.
That'd be good.
Wednesdays or Thursdays in person usually work better for me.
Yeah. A Wednesday would be good.
Yeah.
Yeah.
sure.
Just tail on in person after this SimPEG meeting or something next week.
That'd be great.
As a thought. Okay.
Yeah, so that's pretty much it. I mean, I'm running my toy example. Unlike Dom, I can't really make as good a use of tiling because it's a large loop, but it seems to be going, yeah, not so bad. So I've got my my dipping plate that I'm trying to recover with UTEM and sort of recreate the example that I had with the SIL mesh code, because it's just more impactful if it's in 3D. And then tomorrow, I guess I'm hoping maybe somebody can help me get set up with running a larger scale problem on the cluster.
Yeah.
So I have a pretty example.
Sounds good.
Yeah, that's about it.
Thibaut, you made it.
Yeah, very late. I just thought I would connect, say Happy New Year to everyone.
Happy
and
New Year,
see what's
Thibaut.
going on.
Happy New Year, man.
Oh, and welcome to the new faces. I don't think I know everyone at the UBC side right now, beside you, Lindsay. So hi, my name is Thibaut.
I'm Art.
Nice meeting you, former PhD student and postdoc from UBC, but working in exploration now. But yeah, I guess I don't have much of an update, but I'm just gonna renew interest. I know, Devon, you've been looking on EM plates, cannot help really on the inversion, but if you're working on the analytics and the plate modeling, happy to have some collaboration on that, or like further discussion at some point. We'll let you know as well what I do on that front. And it's not really an update, but I will share in the chat. I was an issue that we discussed several times before the holiday, so I just want to put it back up front about the B field simulation versus H field simulation for B field. I haven't had time to dive into why they are doing different, but I think that's something what is worth we look at some point.
Yeah, that's
Okay.
really fair. I said, well, I trust the H field simulation. I've done a lot of testing with that. The B I have not. So
It's weird because for me, I get good results with B field, but that's a H field that looks weird to me in that example.
oh, okay. Well, we'll do some.
Yeah, no, exactly. It's like maybe I've done something wrong, but Sogi sounded like he was having similar issues too. So
Yeah, it's totally fair. We haven't hit on solving those. So.
And I'm using the B field simulation a lot for ground source EM with B field, and I've done a lot of comparison with EM1D, AltSpace, and Sphere, and so on, and like things line up perfectly. So I trust very well the B field, but somehow the H field in that case is just looks.
And what
out.
type of source are you using, Thibaut?
Was that
A grounded source?
Yeah, well, I don't remember I don't remember for that example, that issue. I put my notebook in the issue, so we can reopen it. I just don't remember if it was a circular loop or a line current, but yeah, well, it's a ground loop. Like I'm doing a lot of modeling of squid systems, like so ground surface EM.
Okay. Oh, we'll get on that and double check.
Sounds good.
Yeah, happy to help too. So, like, it's not on my priority list right now, but so I will not tackle that alone. But if there is someone that wants to start to look at that, I'm more than happy to collaborate on that.
Great.
Awesome.
Okay. Well, doubt there's anything else, so. See you guys all next week. Nice seeing you.
All right.
Sounds good. Have a good one, guys.
Take care.
Good to see you all.
Peace.